let's travel from the American School of The Hague all the way to my home country, Denmark. Solar power in Denmark has a goal to use 100% renewable energy by 2050. The goal of 200 megawatts of photovoltaic by 2020 was reached 8 years early, in 2012. And 36 megawatts is being installed each month. A total of 3,400 megawatts is expected to be installed by 2030. Many solar thermal districts heating plants exist and are planted in Denmark. The island of Engery, a large solar thermal district heating plant on the island of Engery, provides 1/3 of Marstal's energy and is still being expanded. They use seasonal thermal energy storage in the form of a large lime pit that is filled with gravel and water and insulated on top. This enables solar heat collected primarily in the summer to be used year-round. Ballstrup. The community's solar district heating system stores heat in a borehole facility that uses 19,000 cubic meters of underground strata as a heat battery. 2 water tanks provide additional heat storage. When extracting heat, a 1.5 megawatt heat pumps boost the temperature to 80 degrees Celsius for circulation in the district's heating loop. The present system is the first expansion of an original smaller system and now provides 20% of the community's heat on an annual basis from a solar collector area of 10,600 square meters. Step 1. Solar power cells convert sunlight into electricity using the energy of speeding photons to create an electrical current with a solar panel. When this radiation is absorbed by the solar cells, a chemical reaction occurs, causing rapid electric movement. The electrons are forced to move in one direction, creating direct current. And remember, this tremendous energy from the sun is abundant. And here, sunlight falls on a semiconductor, causing it to release electrons. The electrons flow through a circuit that is completed when another semiconductor in the solar cell absorbs electrons and passes them on to the first semiconductor. Last step, inverter. This converts solar electricity for household use. Hi. Okay, so I've been asked to say the different aspects of which solar panels also interact with, starting off with the social aspect. From a developing world, if women didn't have to walk around for 4 hours gathering firewood or pumping water by hand, they would be able to learn to read and write maybe instead, because they could have so much spare time. And instead of collecting and doing all that work manually, they could use a solar oven, or they could also have an electric pump run by solar energy. The economical aspect. A solar-powered home generates between 75 to 100% of its own power, resulting in immediate savings now and increased savings in the future as the cost of electricity increases with inflation. Solar panels have a lifespan of 45 years. Now, as a political aspect, many governments plan to increase their use of renewable sources. For example, the European Union has already produced 12% of their energy from renewable sources. Environmentally, it is a renewable source, thus meaning it will reduce the environmental problems caused by the use of non-renewable energy. However, do keep in mind all sources of energy, including renewable source, affect the environment. Culturally, solar cells have great potential for the use in developing countries, where energy consumption is minimal and electricity distribution networks are limited. As of right now, solar cells are providing energy for more than 1 million households in the developing world. And lastly, the ethical aspect. Morally is the right thing to do. It is saving our home, our future, our Earth.